Just to check, yeah. I would think that the reason you joined was because you struggled with math in school, right? And the topic probably piqued your curiosity. Yeah. So I like to share a few things. Okay. If you're one of those who struggle with maths and a lot of things don't make sense. Teacher says do this, you just do, okay? But then as you went up higher to secondary, the math got more and more difficult. And then at some point you'll be like, what in the world am I doing? Why am I even bothering to learn math? Okay, so actually the reason for this talk is about that, all right? And just so you know, I'm not one of those, okay? I love maths, okay? And if there are those among you here who are into engineering or, actuarial science and all that, where there is a lot of maths in there, and you'll be very happy with that, this will help you understand the rest of the people who are not like that, okay? So it was only in my 30s, okay, that I came across this Mortensen math, and I recommended to my sister, who never liked maths. Okay, she gave up on maths after I think about 1 month, and so when she went and she came back, she was so excited. She went for the course, and every day she comes and she's excited. She's telling, "Do you know this is this is the energy she had." It's like. So my sister is Ann Tam, okay, who was speaking earlier, and it was so funny. So there she was going on and on. It's like, do you know this is? So for the first time she understood maths, and then so after about 20 minutes going on, like, do you know this? Do you know this? And she was just showing me everything. Then she looked at me and said, "Why aren't you excited?" So my reaction was, I've always known that. So it was so funny. Because I never knew that she was struggling like that, and for me it was just it just came naturally. So that's when we understood the idea that there are people who are math inclined and there are people who are non-math inclined, and it's not your fault. It's just it's how your brain is wired, okay? And then, but the fact that she could understand math at that age, right? That means there was something that was done that made it make sense for her. Right? And that's what we've been doing with our program to make sure that it makes sense. And the interesting thing is that statistically, all right, only 20% of people are math inclined. 80% are not. So those of you who struggle with maths, okay, you are among the majority. But guess who teaches? The people who love maths, okay, the math inclined people. Guess who writes the textbooks? Also the math inclined people. And then guess who creates the curriculum for math? Also math inclined people. So if you never liked it, it's like you're doomed for that, okay? Because it was not designed for you, okay? So the thing is, then what is it that's going to take, okay, that will make math make sense for the 80% of people? So with this, okay, we actually develop our program so that people won't find that math is so difficult, right? So the earlier the students join us, the stronger their foundation will be, all right? And what we have to do, even until now, yeah, if we're going to introduce a topic and we as we create the curriculum, I will normally check with Anne, okay, and say like, okay, if I explain it this way, does it make sense? All right, and if it's clear, everything is this one, she'll say, okay. Otherwise, no, cannot. Then we'll have to go back and figure out what other ways are there to explain it, right? Now, I just want to put it into context, yeah? In order for a child to learn math, okay, there is actually a progression of steps, progression of steps that they have to go through. All right, and then it will make sense. So for those who are non-math inclined, these 3 steps are crucial. You skip one, that's it, okay? Now, every single thing in maths is abstract, all right? Now, when a child starts to learn, all right, abstract is not where they start from. You have to start from something concrete. That's why children, even as a baby, they'll grab things, right? Because they want to feel it, they want to experience it. And that is what concrete is about, okay? They need to see, they need to feel, they need to play with things, all right? And then it'll make sense. And then the next step, okay, that needs to move from concrete is pictorial, right? Once the child has experienced like what a dog is like or what a square is and so on, then you draw a picture, okay, it links, right? Now it makes sense. I'm looking at this square, all right? And on a picture, I remembered the square that I was playing with, all right? Or if I see a picture of a dog, okay, then it links to the dogs that I've seen, all right? So this is the pictorial side of things, okay? And then the last part is abstract, right? Now, when you teach your child the number 2, okay, you write 2, that is abstract because it's a symbol, all right? Essentially, 2 is 2 things. So if you count 1, 2, that is concrete. You take 2 sweets and you show it to them, right? And that is concrete, okay? Next time when you draw a picture of 2 sweets, okay, then, okay, so it's connecting the concrete to now the pictorial. And then later, as you show them the 2 sweets and you write the symbol 2 next to it, then you move them to the abstract, okay? Every single step of maths needs to go like that, okay? So if you have like wondered, why is it that when I divide fractions, okay, I'm sure all of you are taught this. If you have to divide fractions, you got to take the second fraction, flip it over, and then change it to times, right? So how many of you actually asked your teacher, why am I doing this? Okay, now I know that very often, okay, the teachers may not even know why. They'll tell you, don't ask, just do it, correct? And even until now, sometimes when I interview teachers, okay, who want to teach maths, I'll ask them, okay, do you know? And some of them will be like thinking, no, quite a number do not know why, okay? Because they're people are math inclined, it'll just make sense to them, okay? Instinctively, it'll just make sense, all right? There are a few other qualities of math inclined people, like we're always looking for shortcuts. Okay, I'll look for the shortest way to do things. That includes from when I was primary school, thinking in terms of walking across the field. I want to cut across a rectangular field, but I have to walk along the path, okay? That frustrated me because that's not the shortest route, right? So, little things that will tell you whether you're math inclined or not, yeah, will be like, for me, I see numbers, I love it. Okay, I see card number plates, I'll be looking at whether the number is divisible by 3. I don't know why, right? When I look at the card number plates, also the alphabets, right? I'll be looking at the patterns, whether the numbers are moving fast enough and what's the next alphabet that's coming up and things like that. Yeah, it's just the part of being math inclined, okay? And I'm very sure that those of you who are math inclined here, you will resonate with that. And it may not be exactly like that, but the general trend is that when you see numbers, it actually excites you or it makes you happy. Or the other one is that you're always looking for patterns, looking for shortcuts. These are all math inclined people, okay? So what I'd like to share here, okay, just 1 or 2 things, okay, to make you see why it's because of how you were taught maths, okay, by math inclined people, okay, for sure your math teachers are math inclined people, right? That's why math was such a struggle, okay? So, and we really empathize with that. So we don't want that to be the situation for our students, okay? So what we do with our students is like, if they're not sure about things, they ask until it's very clear. And the other things that I just want to share would be like, if you were told in maths, okay, if you add x and x squared, it's still x and x squared. You cannot add them together, right? Have you ever wondered why? It's x after all. Why can't I put them together? Okay, so I'm going to share with you how we can show, okay, why they are not the same. Okay, so I'm quite sure you might have crossed, I can't remember the Malay term for it, but the idea of unlike terms, okay, they're different and therefore you can't add. But why different? Okay, then the other thing is also if you have to convince your children why they have to learn maths, all right, because for yourself probably it'll be difficult to answer as well because you probably never use maths as well as an adult, okay, at most to add, subtract, multiply, divide, right? Because essentially that's what maths is all about. Okay, so then if you had trouble figuring out how to answer your child and it says, why do I even have to study maths, right? So essentially maths trains a number of skills. Okay, so if this will help you to convince your child, I'll share this with you. First thing is that we talk about problem solving, right? So in maths, there's so many problems that the kids have to solve, and there are different techniques. Okay, and these are all skills that the kids would pick up, all right, and be able to apply it elsewhere. But then if the teachers don't talk about it, it just mention that, okay, this is a math problem and you have to figure it out, then it becomes silo, right? You're just learning for the sake of maths. But the reality is that the skills that they're learning can be applied anywhere, because in real life, when you go as an adult, does your boss come and give you, okay, here, this is a word problem, go figure it out? No, right? So there are other things that you have to consider, like actually what exactly is the problem, and then actually create the problem statement and then figure out how to answer. And then how to answer, there are many, many different approaches, right? And these are some skills that are picked up in maths. The other one is recognizing patterns, right? Parents, I'm not sure if you are aware, every single formula that is found in physics, chemistry, anywhere, right? In all the maths formulas, they're actually somebody recognizing that there was a pattern, right? So actually, what's more important that kids learn, not to memorize so much the formula, but to understand that being able to recognize patterns can make life easier. Okay, so this is actually another skill. All right, so what else is there? The other one is being able to create a problem. Okay, the problem statement, identifying that there is a problem, right? So in our schools, we actually get the students to give them the other way around. Okay, this is the answer. Can you figure out the question? All right, it's something like what Jeopardy does. Okay, you give the answer and you figure out the question. So in that way, they are formulating what goes before that. Okay, so and then why algebra, right? Unless you go into engineering, okay, you won't really have to do much algebra, right? However, any form of science will have formulas in there, and that's essentially what algebra is. Okay, and we simplify it for the students to say that algebra is basically numbers, right? Numbers in the form of alphabets, that's it. Right? There's nothing mystifying about it or difficult about it. Okay, so I'm going to share my screen and show you how we show kids, okay, why x and x squared are not the same. All right, so let me get to this. Okay, now just checking, can somebody confirm you can see the screen I'm sharing?
Yes.
Yes, we can.
All right, so let's say, okay, this is a rectangle, right? Wait. But before that, okay, I want to, let me think. Okay. Let me start with this, okay? So this is a rectangle. I'm going to tell you that this length here is 1 unit. Okay, and this length, I have no idea how many units it is. And because I don't know what it is, I'm going to call it x. All right, this brings on the idea of unknown. Okay, but essentially it is something we don't know. All right, I'm just going to call it x because I don't know how many ones makes up this x. All right. Now, then we have another piece here. Okay, where this length is also x and its width is x, right? Now, if you look at these two pieces, if this side is x and its width is 1, right? Essentially, the area is x. Okay, so this represents x. Now, then we look at this piece. If the length is x and the width is also x, you're looking at x squared. Okay, now if I ask you to add x and x squared, right? Basically, adding is about counting, right? How many of something. Okay, so like if I say 2 apples plus 3 apples, I count that all together 5 apples, right? So here I'm talking about x and x squared, right? They're different. How to add? Does it by adding them? Okay, if I do this and I put them together, do I get 2x squared? No, right? Let me put it here. Okay, do I get 2x squared? No. Do I get 2x? No. You still have 1x squared and 1x. Okay, so again, the idea that you're actually counting. Okay, now then I would like to show you one more thing. Okay, when you had to multiply x plus 1 times x plus 2, okay, I'm very sure your teachers would have told you, okay, do x plus x times x plus x times 2 plus 1 times x plus 1 times 2, right? Why in the world are you doing that? How did it become, so essentially this will be x squared plus 2x plus 1x and then plus 2, okay? But why? Right, so we believe in showing the students this, okay? And in order to show that, I would first have to start with this idea of if you had to do 2 times 3, okay, this is how we start this. Actually, right now I'm showing you pictorial, okay, because if we had a live session, I would be able to show you the concrete. We actually have little pieces of plastic, right, that we can demonstrate this. Okay, so if parents, if you like to do this with your children, right, you can actually go to any toy store. Those blocks that are squares, cubes, and so on, you can use those, okay, to demonstrate this, right? So now, one of the things that is done here is like when students are told 2 times 3, okay, so they have to memorize 2 times 3 is 6, 2 times 4 is 8, and so on. But why not show them what it means? Okay, so if I say 2 times 3, it actually means 2 taken 3 times. Okay, 2 taken 3 times. So what does that mean? It means I take the 2, okay, and then I need to take them 3 times. So this is 2, okay, and I need to take them 3 times. So I'm going to build it up 3. Right, so let's do this. I put here another one. Oops. One. Now, if your child is 3, 4 years old, even younger, and you showed them this, as long as they can count up to 6, they'll be able to give you the answer. Right? 2 taken 3 times, what is it? 6. They can count 1, 2, 3, 4, 5, 6. Okay? So this is how the concrete can be can teach kids from very, very young. Okay? Now, so then what about this one? Just now what I mentioned, x plus 1 times x plus 2. So if we take the same approach, right? 2 taken 3 times, right? Then x plus 1 times x plus 2 is x plus 1 taken x plus 2 times, right? So essentially, what we need is here, across is x plus 1 taken x plus 2 times. Okay, so earlier I introduced to you x squared and x and so on, right? So now let me demonstrate this. Okay, so this length here is x. Okay, and this length here is 1. Okay, so all I basically need to do is to form a rectangle. So then we take another piece. Okay, to build my rectangle. So this is x. And I need to add 2, right? So let me take 2 pieces from here. Sorry, you got to be a bit patient because this is slower than normal. Okay, I think I got to move everything down a little bit. Okay, so here we have okay, this length here is x, and this little bit here is 1. Okay. Here, x, 2 pieces here, 1, 1. All right, so you get x plus 2. Now all I have to do is fill up the rectangle here with the pieces that we have. Okay, so if you see this area here, I'm just going to highlight this. You have a width of x and a length of x, right? Which means that I can fit an x square in here. So let's do this. Okay, I'm going to pick my x square piece and take it down there. Okay, and this can fit in here. So this one I need to move it a bit. All right, and then over here I can fit this piece here, the x square piece, the x piece, sorry. Okay, so sorry, this is a bit clumsy. Okay, so I now have my x plus 1 across, okay, and it's filling up the rectangle. So there's a little bit more to go. Okay, so now I'm going to use this piece. Okay, this piece can fit nicely, and this piece too. All right, but there's a little bit of gap over here, and that will be filled by the 1s. Okay, so I don't know if I can take out the 1 easily. Okay, so because just now this length here, the same as the width of the x, this is also the width of the x, so this is essentially the 1. All right, so I'm going to put this piece here. Okay, now what is obvious now are the pieces that make up x plus 1 times x plus 2, right? And if you look at the pieces, okay, there's 1 x squared, okay, and this is x, x, and x have 3 pieces of x, right? Plus, there are 2 pieces of 1, so therefore 2. And that's why x plus 1 times x plus 2 works out to be x squared plus 3x plus 2. Can you see the power of learning math this way? So the students don't have to just memorize. Okay, my teacher says do this. Okay, then I just do. But I can see for myself why x plus 1 and x plus 2 multiplied together gives this, right? And it doesn't stop there, because this, by showing math this way, you can also show them the part where this one can actually be broken down into x times x plus 2 plus 1 times x plus 2, because instead of just taking like this times this times this, drawing the loops across, expansion of this multiplication actually means this: x times x plus 2 plus 1 times x plus 2. Okay, and you see it here. Let me separate it out as best I can. Sorry, this one extended itself. Okay, I'll do this first. Okay, can you see that this part is x times x plus 2? Okay, because across is x, going up is x plus 2. Okay, sorry, I'm a bit messy because of the lines get stuck together. Okay, let me complete it like this. Okay, and on the other side is your 1 times x plus 2. And that's why this works out to be x squared plus 2x. You see this part, okay? The left side of this, okay? And then plus x plus 2, which is what this is. Okay? Now this is very important, because what follows this topic, right? So if this makes sense to the children and it's connected with how they learned multiplication, right? And then the next part is factorization. Okay, in maths we call it factorization. In reality, it's actually finding the factors of a number. And students who understand this, the 2 by 3, okay, division is about, if I take 6 divided by 2 or 6 divided by 3, I can make the same rectangle. And factorization is just going the reverse of expansion, which is multiplication, and in reality is actually division. And we also get the students to do this using these pieces to learn factorization, right? Then of course, we can't expect the kids to be always drawing or having pieces to put together and all that. Then we teach them the method, okay? Because first they must understand why is it like this, and see for themselves and make sure it makes sense. Then we have to go with the abstract, okay? Because otherwise it'll be at a disadvantage. It's going to take too long, right, in exam. So we teach it like that. And before we introduce formulas, we get the kids to discover it for themselves. For Pythagoras theorem, we don't just tell them a squared plus b squared is c squared. We get them to make a jigsaw puzzle, and they can see for themselves why a squared plus b squared equals to c squared. The other one is, if you remember trigonometry, sine, cosine, tangent, and until now, like when I hold classes for parents, first thing I see is like surrender. They've forgotten, because quite often you talk about after exam I throw everything back to the teacher, right? Or I burn my book so it's no longer there. But what we do is we get the kids to discover and understand what exactly is sine of an angle, what exactly is the cosine of an angle, and the tangent of an angle. They discover for themselves, and then they'll go, oh, that's what it means. And when I do this with parents, I get the same reaction from parents too. Right? Maybe 20 years later, they suddenly realize, oh, that's what I've been studying all this time. Okay, so I'm going to keep it at the time slot that we have. Okay, so parents, I hope that what I've shown you makes sense, and that you don't feel so bad that you are struggling, because really it's not your fault. It's just maths was not taught the way you needed to learn. That's all. And over again, when I show people this, okay, then they're like, why didn't my teacher teach me this way? Why didn't I learn it this way? You know, they get so frustrated. And I've got colleagues who, when I was teaching in Singapore, they'll be saying, especially the humanities side, yeah, the heads and the teachers is like, oh, if I had learned this, I wouldn't be so bad at maths, you know, I wouldn't have hated maths. That was the other one, right? So this is my sharing for today. So if you'd like to know more, you can connect with me. I'll still be online with the chat, okay? All right. So thank you so much for your attention, parents. Bye-bye.